Hi, good evening 9th standard students. Let us today explain a new topic, namely velocity of a body. In the last video we have studied speed of a body. Do you remember the definition? I will say. The speed of a body is defined as the rate of distance travelled. Rate of distance travelled means what? Distance travelled by time taken. In a similar way, we want to define the term velocity. You see, velocity of a body is defined as the rate of displacement of the body. That is equal to displacement divided by time taken. And this also can be written as speed in a specific direction. Speed in a specific direction. Why I am writing this as a speed in a specific direction is because displacement is defined as what? A distance travelled in a specific direction. Therefore, velocity is otherwise called as the speed in a specific direction. Okay. Now, what is the SI unit of displacement? It is meter. And the SI unit of time taken is second. Therefore, the unit of SI unit of velocity, SI unit of velocity is equal to meters per second. Now, the term second is in the denominator. If I will bring it to the numerator means its power will become negative. So, this can also be written as meter second power minus 1. But how to read this? How to read this? As meter per second. You don't understand? So, how do you define velocity of a body? It is defined as the rate of displacement of your body, which means velocity is equal to displacement divided by time taken, and its SI unit is meters per second. Okay, now let us take an example. So, this is a straight line. Let us assume this is a straight line. And a body is moving from a point A to B 10 meters in 2 seconds. So A to B, how much distance the body is moving? 10 meters. How much time it has taken? 2 seconds. Similarly, I will take B to C, another 10 meters. Again it consumes only 2 seconds. Then C to D, it travels another 10 meter. Here also it has consumed only 2 seconds. Now you look at the points A and B. What is the displacement of the body is 10 meter and the direction is A to B. So what should be the velocity of the body here? 10 meters divided by 2 seconds, that is equal to what? 5 meters per second. From B to C, what is the displacement of the body? Again 10 meters and the time is 2 seconds, and here also this is equal to 10 meters by 2 seconds, that is equal to 5 meters per second. In the same way, the displacement of the body between C and D is also equal to 10 meters, and here also the velocity is equal to 10 meters by 2 seconds, that is equal to 5 meters per second. In this example, we can very well see that the velocity of the body is the same between the points A and B, B and C, and also C and D. Why? This is because the body covers equal displacements in equal intervals of time. Do you understand? So, the body covers equal displacements in equal intervals of time. That is why its velocity is uniformly constant. This velocity only is called as uniform velocity. This is a uniform velocity. So now we have got a new definition for a uniform velocity. What is meant by uniform velocity, or when is a body said to have uniform velocity? A body is said to have uniform velocity when it covers equal displacements in equal intervals of time. So uniform velocity corresponds to what? Equal displacements. This point is very important. Equal displacements in equal intervals of time. In equal intervals of time. Did you all understand? Now in the same example, what should have happened? What should have happened if I assume that this first 10 meters is travelled in 2 seconds and the next 10 meter is travelled in 4 seconds and the last 10 meters travelled in 1 second, for example. So let us assume this example. What is the displacement between A and B? Yes, you tell me. It is 10 meter. Good. B to C also it is 10 meter. Okay. And C to D also 10 meter. But the intervals of time will be different. For example, I have considered like this. So here the velocity must be equal to what? 10 by 2 is equal to 5 meter per second. And here 10 by 4 is equal to 2.5 meter per second. And the last one is what? Here 10 meter per second. In this example, though the displacement of the body is equal between A to B, B to C and C to D, but the time taken is different. In this case, the values of the velocity is not the same. So it cannot be an example for uniform velocity. Okay, one more example, better one I will take. So normally in this example, say for example here this is a 10 meter, this is a 20 meter and this is a 30 meter. So A to B, the displacement is 10 meter. In all the cases, let us assume the time taken remains the same. The time taken by a body remains the same. So between A and B, what should be the velocity, you tell me? Yes, it is 10 by 2. Good, that is 5 meter per second. So velocity, this is equal to 10 by 2. So this is equal to 10 by 2 is equal to 5 meters per second. Yes, you tell me now, between B and C, what should be the velocity? Yes, displacement 20 by 2. 20 by 2 is how much? 10. You are right. So this is velocity is equal to what? 20 by 2. That is equal to 10 meters per second. Yes, now you try me. You try. What should be the velocity between C and D? It is 30 by 2. Yes, what is 15? Okay, good. So here the velocity is equal to 30 divided by 2 is equal to 15 meters per second. So between A and B, the velocity is 5 meter per second. Between B and C, the velocity is 10 meter per second. And between C and D, the velocity is 15 meter per second. Are they equal? No. Are they same? No. So the velocity is not uniform. This type of velocity only is called as non-uniform velocity. Previously we studied what is uniform velocity. Uniform velocity means what? Equal displacements are taking place in equal intervals of time. But here you see the displacements are unequal. That is very important. So what is a non-uniform velocity? In non-uniform velocity, when is the body said to be non-uniform velocity? When the body undergoes unequal displacements in equal intervals of time. This is only one example. Another example also can be given for this. Before that, you just tell me what is uniform velocity and non-uniform velocity. Yes, uniform velocity. A body is said to have uniform velocity when the body covers equal displacements in equal intervals of time, and a body is said to possess non-uniform velocity when it covers unequal displacements in equal intervals of time. Okay, students, we are going to the next topic. Shall I rub the board? Okay, fine. Let us see another example for non-uniform motion. You look at the board. This is a circular path a body is going to move from the starting point A. So A is the starting point. It moves towards B along a curved path. And let us say, for example, A to B, the curved distance is 10 meter. And the time taken is 2 seconds, for example. 2 seconds for example. Next, the body is moving from B to C another 10 meters, and here also it has consumed the same time. And from C to D also it travels 10 meter and has consumed the same time, 2 seconds. Similarly, from D to A it is traveling 10 meters in 2 seconds. What is the actual path along which the body has traveled? Good, it is a curved path. So, the distance A to B along the curved path is equal to 10 meter. A to B curved path, the distance traveled is 10 meter. Can the displacement also be equal to 10 meter? No, it cannot be 10 meter. Before that, how will you find the displacement AB? That's good, by drawing a straight line between A and B. I will join A and B with a straight line. This shortest distance AB, this shortest distance AB only will be equal to the displacement of the body. Anyhow, the displacement BC I will find out. You see that the displacement BC is acting along some other direction. Then the displacement CD is found by joining C and D by a straight line. And last, the displacement from D to A is also found by joining the points D and A by a straight line. Since the distance travelled between AB, BC, CD and DA all are equal. Similarly, the displacement AB, displacement BC and displacement CD, displacement AD also should be equal. Is displacement a scalar or vector? That's good. It is a vector because it is having a specific direction. So I am going to represent the displacement AB. Displacement AB is equal to displacement BC, that is equal to displacement CD, that is again equal to displacement DA. All are equal. And how much time is consumed by the body to make these displacements? Same time, 2 seconds only. Everywhere it consumes the same time. Okay. Now as per this example, does the body covers equal displacements in equal intervals of time or not? That is excellent. Good. The body has covered equal displacements in equal intervals of time. So, is it uniform or non-uniform velocity? Yes, it is non-uniform velocity. But some may mistake this to be uniform velocity because equal displacements are covered in equal intervals of time. But still, how come it be a non-uniform velocity? Yes, that's good. It is because the direction of motion is changing. The direction of motion is changing. You see, the direction of AB is different from direction of BC, and still it is different from the direction of CD and DA. So this is what I said, that the definition for non-uniform velocity must be precise. A body is said to have non-uniform velocity. What are the points we have highlighted already? First, unequal displacements. Unequal displacements. Okay, in equal intervals of time. Unequal displacements are made in equal intervals of time. And the direction changes. The third one is direction changes. Direction changes. So in this example, what is changing actually? The direction of motion is changing, though the magnitude of the displacement remains the same, but the direction of displacement changes. So the body is having non-uniform velocity. Did you all understand? Yes. Now let us come to this example. You are all eagerly waiting to do the problem. I think you are going to solve the problem. Let me take this example. Okay students, a body is now moving from P to Q, a distance of 100 meter. Since it is a straight line path, what should be the displacement also equal to? Good. Same 100 meter only. So P to Q distance as well as displacement will be the same 100 meter. How much time is being consumed by the body? It is 4 seconds. Good. Then Q to R, how much distance it has covered is 50 meter and it is taking place in 1 second. Similarly, R to S also, the body is traveling along the same straight line. It travels 150 meter in 7 seconds. Okay. Now, I am going to find out what is the average velocity of the body. Average velocity of the body. It is similar to that of average distance traveled. Yesterday we have studied, is it not? Yes. Can you tell me what is average speed first of all? How will you find average speed of a body? Yes. We have to divide the total distance traveled by the total time taken. Okay, now you tell me, in this example, how will you find the total displacement of the body? You tell me. So, this is an average velocity. The average velocity is equal to total displacement. The total displacement divided by what? Total time taken. So, it is the total time taken. So, you add P to Q 100 meter, Q to R 50 meter, R to S 150 meter. So, the total displacement is equal to what? 100 meter plus 50 meter plus 150 meter divided by, you add the total time taken, 4 plus 1 plus 7. So, this is 4 second plus 1 second plus 7 second. Yes, you tell me what is the total displacement now? 150 plus 150 is 300. Okay. So, this is equal to 300 meter. And what is 4 plus 1? 5. 5 plus 7 is 12. Good. So, this is 12 second. Now, both are divisible. Both are divisible by 3. So, 300 can be divided by 3, that is equal to 100. And how many 3's are there in 12? 4 3's are 12. So, this is equal to 100 by 4. And that is equal to 25 meters per second. 25 meters per second. So, what is the average velocity of the body? It is found to be 25 meters per second. Okay, now if I will ask you specifically what is the velocity of the body between P and Q, what should be the velocity of the body? You tell me. Yes, 100 by 4. That is how much? Yes, that is also 25 meters per second. And between Q and R, what should be the velocity of the body? Yes, it is 50 meters per second. So, in this first interval, it is 25 meters per second. The second interval, it is 50 meters per second. And this is 150 by 7. If you divide, means neither 25 nor 50 meters per second is coming. So, individual velocity between any 2 points along its journey is not same. In such cases, we use the term average velocity of a body. So, the average velocity of a body is defined as the ratio of the total displacement to the total time taken. And in this example, we find that it is equal to 25 meters per second. Now, a simple question I am asking you. Look at this circular path. In this example, you see that body starts from which point? A. It passes through which points? B, C, D, and it is coming back to A itself. Okay, you add what is the total distance traveled by the body? Total distance traveled is how much? 10 plus 10 plus 10 plus 10 equal to what? 40 meters. What is the total time taken? 2 plus 2 plus 2 plus 2 is 8. So, total distance traveled is 40 meter. Total time taken is equal to how much? 8 seconds. So, what should be the average speed of the body? What is the average speed of the body? It is 40 divided by 8 is equal to 5 meters per second. Is it not? Okay. Now you tell me what is the average velocity of the body in the same example. Exactly, you are right. Good. It is equal to how much? 0. Excellent. Why it is 0? You tell me now. Yes, because The starting point and the final point are one and the same. Though the distance traveled is 40 meter, the displacement is equal to 0. If the total displacement is equal to 0, then 0 divided by any time is also equal to 0. Yes, you have understood very well. Okay, students, now we are going to the next topic. So after this average velocity, one more definition is also there for average velocity. So I am going to erase the board. Have you all taken this answer? Have you taken? Good, fine. We are now getting another definition for average velocity by considering a very simple example. Okay. Now let us take a point A at which a body is at rest. So when the body is at rest means what should be its velocity? 0 meter per second. Good. Let us imagine that it has started from rest and it is moving towards another point B. The moment when it reaches the point B, the velocity of the body is found to be 10 meter per second. Okay. So this from 0 it has acquired a velocity of 10 meter per second, say for example in 2 seconds. Understand that? Then when it reaches the point C, its velocity has changed to 20 meters per second. So for this B to C also it has taken 2 seconds. So if you see 10 minus 0, 10 minus 0 is 10. So the change in velocity has taken place in 2 seconds. Similarly, 20 minus 10 is also 10. The change in velocity is 10 meter per second. And for this also it has covered how much time? 2 seconds only. So what we must understand from this example is the velocity of the body changes by equal amount. So in such a case, if you consider the initial velocity of the body at B is denoted by the symbol U, and the final velocity of the body at C is denoted as V. Now we get another definition for the average velocity. So average velocity, the average velocity of a body is equal to the initial velocity plus final velocity divided by 2. It is just like taking the average of two numbers. So initial velocity is denoted by what symbol? It is small u. So this is equal to small u plus the final velocity is denoted by what symbol? It is a small v and it is divided by 2. So this is one other definition of average velocity only when the velocity is changes at a uniform rate. Okay. So my dear students, in today's lecture we started with the definition of velocity. I am going to summarize once again. Listen to me carefully. Velocity of a body is defined as the rate of its displacement, or velocity is equal to displacement by time taken, and it is a vector quantity because it is having a specific direction. So velocity can also be defined as speed in a specific direction. Since it is speed in a specific direction, its unit is also equal to meter per second. Then a body is said to have uniform velocity when its displacement changes by equal amounts in equal intervals of time. If the same displacement is changing in unequal amounts in equal intervals of time, then its velocity is said to be non-uniform. But what is a better way of defining non-uniform velocity? A body is said to have non-uniform velocity when its displacement changes by unequal amounts in equal intervals of time. Yes, in different direction. Its direction also may change. Okay, good. Finally, how did we define average velocity? Average velocity of a body is defined as the ratio of the total displacement to the total time taken. I hope you should have understood. So far we have studied speed and velocity. Speed is a scalar quantity because it does not have a fixed direction, and velocity of a body is a vector quantity because it is having a fixed direction. Okay, let us meet you in another new topic, namely acceleration. Before that, we will be solving some numerical problems initially and then go further. Bye.